Hi everyone, and welcome to the A2 Help video. In this video, I'll be going through some of the common questions that as tutors have been getting asked over the past few weeks regarding assignment 2. Through this video, I'll be covering several topics of key questions that students have been asking. I'll start off by giving you a brief introduction to the spec. I'll then be talking a bit about thinking about the constants we might need in our assignment and how to implement them. Talking about methods that haven't been redefined in the spec, but will need to be redefined in your code. An explanation of sub and super classes, as well as an introduction to the super method, which may be useful in your assignment. In addition, I'll also be just talking about superclass and subclass handling and how to use them in efficient ways. Finally, I'll be going through some of the more niche questions regarding the assignment and trouble students have been having. I'll be going through some style hints and things to help you with the style marks of your assignment. And finally, I'll be talking through how your assignment will be marked, both in terms of functionality and in terms of style, and the best way to maximize your marks in both of those areas. So to start with, I'll give a brief introduction to the spec, as I'm sure many of you will be familiar with this by now. As you'll notice, first of all, the spec is a lot longer than assignment 1. However, this does not necessarily mean that it is significantly longer in terms of the work you'll have to put into it. A lot of the methods in this assignment that we're asking you to write are quite simple, and it's towards the end of the assignment, or roughly just after halfway through, that the methods that we're asking you to write do become a bit more complicated, particularly when we have to start thinking of parent and child class behavior. What we're asking you to do is to write multiple classes, and then within each of those classes to write several methods which handle those objects. As you can see in the maze game, we have several different objects. We have things which to do with the walls and the tiles. We have items that the player can pick up. We have the player themselves. We have the maze, we have levels, and of course we have the overall game functionality, which is the final class being Maze Runner. And all of these will lead up to that point. If we go a bit further down in the assignment, you'll notice that there's this diagram which shows essentially how all the classes interact with each other. Now, as you'll see here, there are two types of arrows, one with a white head and one which is a dotted line with a black head. So any item with a white head indicates to us a relationship with inheritance. So for instance, if we had to take an example, we know that we have an entity as a parent class. And then if we look at the white head and follow it down, entity is the parent of the item class. The item class is the parent of potion, coin, food, and water. And finally, the food class is the parent of apple and honey. If we take a look at the dotted lines, this represents something different. This essentially just represents a relationship. And what you'll see is you'll have these numbers on them, either ones or n's. So if we look at inventory, for example, what we're saying is that the inventory class, and then we have this arrow which goes and has 1 to n, contains multiple items, contains n items. So one inventory contains n items. Similarly, we have this player, and what we see is that one player contains one inventory. So there's only one inventory per player. And finally, we know that for the model class, we know that one model contains one player. Similarly, we know the maze contains many tiles. We know the level contains one maze, and we know the model contains many levels. So this is essentially how to interpret this diagram. That may be helpful as you get further through the assignment, thinking about how many instances of objects you might need in particular classes. So that's a brief introduction. Of course, you'll be working through this assignment mostly in chronological order. From Unit 5 in this assignment onwards, there are certain classes later on where you might need to pause and finish another class before you can finish the methods in another one. For instance, within the player class, there are some methods to do with inventory. You won't be able to implement those until you've gone a bit further, finish implementing the inventory class, and then go back and finish implementing the player class. So if at any point you do come across those challenges, feel free to move on and then come back to it, as that's the best way to do it. Something else to consider is constants. In this assignment, you will be using constants quite a lot. We have given you what looks like quite a large constants file. This contains many of the constants to do with the items. For instance, how much a potion will heal a player by, what are the IDs for certain entities on the map. And these things are generally quite useful. You might notice that as you go through your assignment, there might be some that are missing. If that's the case, just include them at the top of your A2.py. You are able to include as many constants as you want. It's important if you are putting constants in to give them a name as a name symbolic constant. That way you can maximize the style marks you'll be getting. Similarly, if the constants you're using are numbers, think about whether this is a magic number or not. If the number represents something, it needs to be assigned to a constant. So for instance, we know that 20 isn't just a miscellaneous number, rather we know 20 is the amount the potion will heal the player by. Hence, what we've done is we have assigned the constant potion amount to the value of 20. So if you think you can add more constants, you're more than welcome to and include them at the top of your A2.py. Another thing to keep in mind is that some of the methods in the assignment have not been redefined. So what do I mean by this? Well, if we look at the tile class, this is the very first class you'll be writing. We have given you 5 methods to write here: is blocking, damage, get ID, string, and repper. And as we can see, you'll be implementing them such that when you run your code, you'll be getting an output which looks like this. However, if I go down to wall, and we know that wall inherits from tile, we can see that wall also uses all these 5 methods. Now, since wall has inherited from tile, it means that it actually inherits directly and it can actually use all the methods that tile has implemented above. However, one thing we notice that is different is that wall is blocking here is true, but in the parent class, the is blocking is false. So in these cases, you might actually, one, need to redefine a particular method such that it gives you the output that you expect for that particular class. Or what you can do is you can think about the way you use class variables. That way you can keep using the parent class methods, but by changing the variables internally in your child class, when you call upon that particular method, you will be getting the output that you expect. What we don't want to see is for all these child classes. So for instance, tile, we have the 5 classes. Wall, we of course, as 5 methods, sorry, for wall, we can still use those 5 methods. For empty, we can still use those 5 methods. What we don't want to see is we go to wall and we see all those 5 methods redefined. We go to empty, we see all those 5 methods redefined. We go to lava, we see all those 5 methods redefined. This would be a pretty big example of code duplication, as a lot of them will be the same across the child classes. However, just think about the ones that will be different. And in doing so, think about what's the best way that I can convey this information without having to redefine everything over and over again. And that way I can make my code more efficient, and this will be better for the style marks I receive at the end. And if you are having trouble with thinking about this, you're more than welcome to ask a tutor in a prac, and we can give you some further tips on how to do this. Something that we've been getting asked quite a lot about is basically to do with parent and child classes, and also essentially how do we get parent classes and child classes to interact, or as some people might be calling them, we have super classes being the parent, the one that comes above, and subclasses, the child classes, the one that comes below. How do we use them and how do we interact with them? Because in this assignment, we are using quite a lot of inheritance, as you can see from this diagram here. So what I'm going to do now is I'm going to run through a little bit of a generic example. Something else I do want to suggest is that the tutorial from last week and the tutorial next week are very important to this assignment. So I can't stress enough how important it is that if you haven't gone to last week's tutorial, that you go back and you attempt it and you look at the solutions. But also for those who are struggling with inheritance, definitely go to this coming week's tutorial. It is very important, as we'll be encouraged studying inheritance and subclasses and superclasses accordingly. So let's discuss subclasses and superclasses. What I've done here is I've created a little example. So what I've done is I've created a class called drink. Now the parent class is essentially, think of it as being the generic class. And the child class has all the attributes of the parent class plus more, all with slightly different changes. One thing that's important to consider is that the parent class doesn't know that the child class exists, but the child class knows that the parent class exists. So think about that in your design. Your child class can rely upon the parent as much as it wants. It can use its information. It can use the same methods, but the parent class won't be using information from the child class. So the inheritance essentially works within one direction. So what happens if I have a child class that inherits from a parent? So let's look at this example. So I've created a class called drink, and this is just very generic. I don't know what the drink is. I don't have much information about the drink except for its temperature. So I can create an instance of drink and I can assign it a particular temperature. And I've also got a method within the parent which allows me to return that temperature. So I can use get temp. Now what I've done is I've gone and I've created a child called T. So T is a type of drink. It's a child of the parent class. And what I've done is I've inherited it here within the brackets. And I'm going to go and I'm going to initialize my drink. And what I'm going to say is, okay, cool. Drink just takes temperature within its constructor. What I want to do is, I know I'm talking about tea. I know tea can also contain leaves and tea can also contain milk. However, tea will also have a temperature. And what I want to do is I want to initialize it not only with these two variables, but initialize it using the drink constructor as well. What we can do here is we can use what's called the super method. And what the super method does is, what I can do is I can write super in brackets. And the best way to think of this is essentially, if we look at super, and then what we do is we say, okay, what is the super of my current method? The super of my current method is whatever is in these brackets here. So drinks, because I know drink is my parent, drink is my super. So essentially this would be the same as writing drink dot init and then putting the temperature argument in. Or similarly, this would actually just be the exact same as taking all the code within my init here and putting it down here. However, what we want to do is we want to relate it to the parent class, hence why we use super. So cool, I'm essentially pulling all this extra parent information into my child. And on top of that, I'm adding extra information as well. I'm adding leaves and I'm adding whether the drink has milk or not. Similarly for coffee, I can say, cool, coffee I know will have beans in addition to temperature and it will also have milk. So same as before, I'll go through, I'll get the same constructor of my parent, which is drink, and I'll initialize it with a temperature. And then I'll set up these variables to contain information about the beans I'm using in my coffee and the milk I'm using in my coffee. So if I go ahead and run this now, we can take a look at how this works. Cool, so I can just say, okay, drink, and I'm gonna have a drink, which is room temperature, so 24 degrees. I go drink.getTemp, and it will return the temperature of the drink. Now what I would know is that actually I'm gonna have a drink of tea, and my tea is gonna have a temperature of 100 degrees. It's going to have black tea leaves, and it will have milk, so I will say true. Now I can go t.getTemp, and it will return the temperature of my tea. In addition to that, we also have internally information about the leaves and information about whether we have milk, true or false. And so what our child class has done is that we've gone and we've actually used the parent methodologies or the parent methods to extract information. But in addition to that, we have added extra information in our child that the parent doesn't know about. So that's the key thing thinking about parent and child classes. When you're writing a parent class and then you're writing a child class, think about, what does the parent know? It doesn't know anything about the child, but the child can know everything about the parent. And in fact, the child can use the parent methods. Just like this way here, my child class T, there is no getTemp written in T, but since it inherits from the parent, since it inherits from drink, it can use the parent method as well. So that's an important thing to think about when it comes to looking at parent classes and child classes and how they work. So one particular example I want to focus on specific to the assignment is the item class. Now, what many of us tutors have seen students do, one second, just froze. Okay, let's go back. So one thing many of us tutors have seen students do is essentially students have written a parent class. So for instance, item is the parent of potion, coin, and food and water. And what they've done is they've gone to the parent class and they've gone, okay, we need to write apply. But what we're going to do is we're going to write apply in the parent class, which can handle for all the children classes, handle for all the child classes. So what they've done is they've said, okay, class item, def apply. If class name is potion, do this. If class name is coin, do this. If class name is food, do this. If class name is water, do this. This is not what we want you to do for this assignment. In particular, this is not what we want you to do for this method. What we have asked you to do in this case is we have asked you in the parent class to raise a not implemented error. That's it. So in your class item, def apply, all you're doing is raising a not implemented error. When you go down to potion, as you can see here, like I was saying before, we don't explicitly tell you every single method to redefine. But what you can see here is that I go potion apply and my player health has changed. So what we need to do is we need to redefine our apply method within our child. So for in this instance, potion, and we can see that potion changes our player's health. So within class potion def apply, we need to use the methods to change our player's health by the potion amount. Similarly, if we look at water, when we apply it, we are changing our player's thirst. And then for food, we are changing our player's hunger. We are not doing these things in the parent, in item. Item in the parent is just meant to be generic and a catch-all. And in this case, we told you we just wanted to raise a not implemented error. In the child classes, you will be redefining the method to be able to handle for the specific things we want this subclass or this child to do. So that's important. Your parent class isn't meant to handle for all the different cases in the child. That's the point of the child class. The child class is there to redefine the methods in the parent so that they are specific to this particular case. All right, so that is most of the technical stuff about the assignment that most students are having trouble with, and hopefully you found that helpful. If not, feel free to ask a tutor in an upcoming practical or also to post on EdStan as well, and we'd definitely be happy to help. Something else I want to touch on is related to style. So one thing that we have been seeing a lot, not only this semester, but all our years tutoring this course, is the way that students name their variables. So as you'll see here, all of my class variables I am naming with an underscore in front of their name. I have not called this self.temp equals temp. I've called it self._temp equals temp. And you might be thinking, well, what's the difference? I can just call it whatever I want. Functionality wise, it makes no difference, but style wise, this is important. An underscore before the variable name indicates that this is a private class variable, or if we're using this for a method, for instance, if I did underscore get temp, it will be saying this is a private class method. What this means is that we can only access this particular function or this particular method or this particular variable within the class itself. So the important thing in this assignment is that all of your class variables, which you're referring to by self, should be using the underscore to indicate that they're private. Essentially, we don't want you going directly into other classes and change their variables without using the setter method. So the getter and the setter methods, that's how you change variables. You shouldn't be changing them by accessing an outside class and directly looking at that variable and changing it. You should be doing it via methods. So one thing that's important, and students lose marks on all the time, is with their class variables, they forget the underscore to indicate that it is a private variable. This is also just important in general. When you're writing your assignment and you're thinking, okay, maybe what I need to do is I need to actually change the player's health, for instance. What you don't want to do is you don't want to go player._health equals particular value when you're in another class. What you want to do is you want to go player.change health, for instance, and then you have a method which changes the health. So the rule of thumb is with Python and with classes, you can only change values of variables within the class itself. And if you are in another class and you want to change it, you have to do it via methods within the class that you want to change. So for instance, player will have a method, perhaps a method you write called change health, and that exists within the player class. So that's how you would change the health from outside of it. You don't want to be accessing the variable directly. This will cause a lot of issues, particularly with the style marking. So on that note, let's take a look at the way that this assignment will be marked. So this is quite similar to A1. In assignment 1, you will have noticed that there was a 40-60 split on style and functionality. In this assignment, there'll be a 50-50 split in style and functionality. So let's talk about functionality first. So very similar to A1, your functionality in this assignment will be marked using Gradescope. The tests are uploaded, and I would encourage you to run through your assignment using the tests at the moment. There is a slight difference in terms of the tests you'll see at the moment. First of all, we're just trying to make this, I guess, a bit more accessible for all the students. So there are two different errors that now come up in Gradescope. So for instance, when you're running your code in Gradescope, you might see this: failed, skipped due to failing, or skipping a test from test model when you're running test maze runner. If you see text like this, what it means is that in order to pass these tests, you must pass all of the tests in a previous class. So for instance, we're in test maze runner, and it's saying, we're not going to allow you to do these tests until you've passed all the tests in test model, just because test maze runner won't work until we know that your test model is correct. So that's the first thing. The second thing is that tests won't run if the class hasn't been defined. So for instance, let's say you're at the start of the assignment and maybe all you've done is tile. That means that if you were to look at the test for player, you would see that it would say something along the lines of test classes defined correctly with tag player in this case. Or in the case we're looking at here, we're looking at tiles and we're trying to see if it's blocking. And we can see that in our assignment, we actually haven't even defined the tile class yet. And for that reason, the tests aren't going to run. This is just to make things a bit more readable for all of you. And that way, hopefully make it a bit more approachable and less daunting with all the crazy output you can get on Gradescope. The second thing is just the style in general. So it's very similar to assignment 1. So we're looking at program structure with just white space and the number of characters in a line. Descriptive identifier names, make sure you're not using Hungarian notation and make sure that the variable names mean something. Named constants, which I spoke about at the beginning, using named constants and not magic numbers throughout your assignment. Documentation, you should be well familiar with this now. So your commenting and your doc strings. Algorithmic logic, so this is similar to assignment 1 as well. Basically, are you not duplicating code? Are you using sensible control structures so you're just not nesting over and over and over again when something can be done a lot more easily? And then finally, we have this new category, which is object-oriented program structure. So this is the style part of your assignment, which is directly related to classes. And it's broken into 3 parts. So first is classes and instances. So it says objects are used as entities to which messages are sent, demonstrating and understanding the differences between classes and instances. So essentially what we're saying here is that when we are in the assignment and interacting between classes, we want to be doing so via the instances of objects, not through creating brand new instances every single time where we can. The next one is encapsulation. Classes are designed as independent modules with states and behavior. Methods only directly access the state of an object on which they are invoked. Methods never update the state of another object. So this is what I was saying before in terms of how we go about changing particular variables. Make sure that if we are changing a variable outside of our class, we are doing it via a method in that other class. So that way we're not just taking a private variable and making a direct change in somewhere that we're not allowed to. And finally, inheritance and polymorphism. We've spoken a bit about inheritance during this video here. So basically, we want to make sure that our subclasses and our superclasses don't break each other, and also that we're not re-implementing behavior that the superclass already handles for. So for instance, a classic example of this would be in the tile class, and then we have all the child classes of tile. We want to make sure that we're not just re-implementing the same thing over and over again if we don't have to and the parent already handles for it. But at the same time, we want to make sure that our child classes don't go and then cause a break in the parent class. So that can be a little bit tricky to understand. But essentially, as long as we're working linearly, it's fairly easy to avoid this. And finally, we also just want to make sure that our child classes do not break the parent's class interface. So your child class does everything your parent class does, plus more, or maybe does everything they do, and some of them are slightly different. So there's a relationship there, and we don't just want to sever that relationship and cause them to actually be disconnected. So that brings me to the end of this video, which covered quite a bit of content on different things. Of course, there's not enough time to go into everything in depth. But if you do wish to speak about any of the stuff I've touched on today further, feel free to come along to a practical over the coming weeks, or even post a question around EdSTEM. And we as tutors would be more than happy to help you. Good luck with assignment 2, and we'll see you next week.